The starting mystery of the Ice Age Mapmakers is one of the most captivating enigmas in human history. For from the very first lines of the story, we are forced to confront a paradox that unsettles everything we thought we knew about the ancient world. How could maps exist that appear to show the coasts of continents centuries or even millennia before they were officially discovered? How could unknown navigators, in an age that we assume was dominated by small local cultures, have charted great shores, measured vast oceans, and depicted the Earth with a degree of accuracy suggesting technologies we do not credit to their era? This strange puzzle is both simple and profound, and it begins to unfold with a fragment of parchment in the early 16th century. A worn piece of map that opens a window into a world that should not exist. Imagine for a moment standing in the hushed halls of an ancient library, the air thick with dust, the silence broken only by the rustle of old paper and the creak of wooden shelves. You pull from the collection a map, faded and delicate, its edges frayed by the passage of time. The ink has browned, the lines are uncertain in places, yet as you study it more closely, you notice something impossible. The map shows coastlines, rivers, mountain ranges that should not be there, not at that time, not with that precision. You look again, your pulse quickening, because what you are seeing contradicts the official narrative of exploration, of discovery, of human progress. This is not just an old map. This is evidence of something lost, something forgotten, something that whispers of a knowledge far older and far stranger than we have been taught. The map in question is the famous Piri Reis Map, created in 1513 by an Ottoman admiral and cartographer whose name has echoed through the centuries. Piri Reis was no ordinary sailor. He was a man of learning, a collector of maps, a student of the sea. His map, drawn on gazelle skin, is a marvel of artistry and detail. It shows the western coast of Africa, the eastern coast of South America, and most startlingly, a southern landmass that appears to depict the northern coast of Antarctica. But here is the problem. Antarctica was not officially discovered until 1820, more than 300 years after Piri Reis drew his map. Even more troubling, the coastline shown on the map does not match the ice-covered Antarctica we know today. Instead, it seems to show the land beneath the ice, the true rocky shoreline that has been hidden under miles of frozen water for thousands of years. How is this possible? How could a 16th century admiral have access to information about a continent that would not be seen by modern explorers for centuries? And how could he depict that continent not as it appears today, buried under ice, but as it might have looked in a distant age when the ice was not there? These questions have fueled intense debate, fierce skepticism, and wild speculation. Some say the map is proof of an ancient advanced civilization, a lost culture that sailed the world, mapped its shores, and then vanished into the mists of prehistory. Others dismiss the whole affair as coincidence, as error, as the result of copying and distorting older maps whose origins are misunderstood. But the mystery refuses to die. It lingers, it fascinates, it demands our attention. Piri Reis himself provides a clue, though it only deepens the enigma. In notes written on the map, he explains that he compiled it from many sources, some of them very old. He mentions maps from the time of Alexander the Great, maps captured from Spanish sailors, maps that had been passed down through generations. Among these sources, he refers to a map used by Christopher Columbus, a map that Columbus himself reportedly consulted on his journey to the New World. This raises an intriguing possibility. What if Columbus did not sail into the unknown as we have been told? What if he had access to older maps, secret charts that showed lands across the Atlantic, maps that hinted at continents waiting to be rediscovered? And if those maps existed, where did they come from? Who made them and when? The Piri Reis map is not alone. It is part of a collection of ancient and medieval maps that display features and accuracies that seem out of place for their time. Consider the map of Orontius Finaeus, drawn in 1531. This map also shows Antarctica, but with even more detail. It depicts the continent as a land mass with rivers, mountains, and coastal features. It shows Antarctica centered roughly on the South Pole, with a shape and size that correspond remarkably well to modern satellite data of the land beneath the ice. Once again, we face the same impossible questions. How could Orontius Finaeus, working in the early 16th century, have such detailed knowledge of a frozen continent that no European had ever seen? Then there is the map of Gerardus Mercator, the great Flemish cartographer whose projection system revolutionized map-making. Mercator, working in the mid-16th century, produced a map of the Arctic that shows features now hidden under ice. His depiction of the northern polar regions includes islands, channels, and coastlines that match, in some cases, what modern sonar and radar have revealed beneath the ice sheets of Greenland and the Arctic Ocean. Again, the question arises: how did Mercator know? What sources did he consult? And where did those sources get their information? These maps, and others like them, form a body of evidence that is difficult to ignore and even more difficult to explain. They suggest that someone, at some time in the distant past, conducted surveys of the Earth with a level of skill and precision that we associate with modern technology. They suggest that this knowledge was recorded, preserved, and passed down through the ages, copied from map to map, until fragments of it appeared in the hands of medieval and Renaissance cartographers who may not have fully understood what they were drawing. The implications are staggering. If these maps are authentic, if they truly represent ancient knowledge, then the history of human civilization must be rewritten. We must accept the possibility that advanced seafaring cultures existed long before the rise of Egypt, Greece, or Rome. We must consider that these cultures explored the world, charted its coasts, and perhaps even visited places we believe were untouched until modern times. But let us slow down and examine the evidence more carefully, for this is where the mystery becomes both richer and more complex. The coastline of Antarctica shown on the Piri Reis Map has been compared to modern seismic surveys that map the topography beneath the ice. In 1949, a joint British-Swedish expedition conducted such a survey, using sound waves to penetrate the ice and reveal the shape of the land below. The results were striking. The coastline of Queen Maud Land, as it appears under the ice, bears a resemblance to the southern landmass on the Piri Reis Map. The correlation is not perfect, but it is close enough to be provocative. Some researchers argue that this resemblance is too specific to be coincidental. They suggest that the Piri Reis Map was copied from a much older source, a map created thousands of years ago when Antarctica was not covered in ice, when its coasts were visible and navigable. This hypothesis leads us into even deeper waters. For Antarctica to be ice-free, we must go back to the end of the last ice age, roughly 12,000 years ago. At that time, the great ice sheets that covered much of the northern hemisphere were melting, sea levels were rising, and the climate was shifting. Could Antarctica have been free of ice during this period? Geological evidence suggests that the Antarctic ice sheet is ancient, millions of years old, but there is some debate about its extent during the late Pleistocene. Some scientists believe that parts of the Antarctic coast may have been ice-free or less heavily glaciated during brief warming periods. If this is true, then it is theoretically possible that an ancient maritime culture could have explored and mapped these coasts before the ice returned. But this raises another problem. Who were these people? What kind of civilization could have possessed the ships, the navigational skills, and the organizational capacity to undertake such voyages in the depths of prehistory? The conventional view of human history does not allow for such a civilization. According to mainstream archaeology, 12,000 years ago, humanity was just emerging from the last ice age. Most people lived as hunter-gatherers, following herds of game, gathering wild plants, and beginning the slow transition to agriculture. There were no cities, no writing, no large-scale states or empires. The great civilizations of Mesopotamia, Egypt, and the Indus Valley would not arise for another several thousand years. And yet, if the maps are to be believed, someone was out there, crossing oceans, surveying coastlines, and recording what they saw with impressive accuracy. This is the heart of the mystery, the reason why the Ice Age mapmakers provoke such fascination and controversy. Let us consider the technical challenges involved in creating such maps. To chart a coastline accurately, you need precise measurements of latitude and longitude. Latitude, the distance north or south of the equator, can be determined relatively easily by observing the angle of the sun or stars above the horizon. Ancient navigators understood this principle and used simple instruments like the astrolabe or cross staff to measure it. But longitude, the distance east or west, is much harder. It requires an accurate clock because the Earth rotates and the position of the stars changes with time. Without a reliable timepiece, calculating longitude is nearly impossible. The problem of longitude vexed sailors for centuries. It was not solved until the 18th century, when John Harrison invented the marine chronometer, a clock accurate enough to keep time at sea. And yet, the ancient maps seem to show longitudinal accuracy that should not have been possible without such instruments. This is one of the strongest arguments made by those who believe the maps are evidence of a lost civilization. They point out that the placement of coastlines, islands, and other features on maps like those of Piri Reis and Orontius Finaeus suggests a knowledge of longitude that should not have existed. Some researchers have proposed that the ancient mapmakers used a different method, perhaps based on astronomical observations or a sophisticated understanding of the Earth's geometry. Others suggest that the maps were created using a grid system, a kind of global coordinate framework that allowed surveyors to plot positions with remarkable precision. But these explanations remain speculative. We have no direct evidence of such techniques being used in antiquity, and the mechanisms by which such knowledge could have been developed and transmitted remain mysterious. Skeptics, of course, offer alternative explanations. They argue that the apparent accuracy of the maps is exaggerated, that the correlations with modern geography are the result of selective interpretation and wishful thinking. They point out that many old maps contain errors, distortions, and fanciful elements, and that it is easy to find superficial resemblances if you are looking for them. They suggest that the southern land mass on the Piri Reis Map might not be Antarctica at all, but rather a speculative or mythical continent, a terra australis that mapmakers imagined must exist to balance the land masses of the northern hemisphere. This idea of a great southern continent was common in medieval and Renaissance cartography, long before Antarctica was actually discovered. So perhaps what we see on the Piri Reis Map is not ancient knowledge, but medieval fantasy. There is merit to this argument. The history of cartography is full of invented places, lands that appeared on maps for centuries despite never having been seen. But the counter-argument is equally compelling. If the southern landmass on the Piri Reis Map is purely imaginary, why does it match, even approximately, the shape of Antarctica as revealed by modern science? Why do the contours, the bays, the coastal features align so closely with what we now know lies beneath the ice? Coincidence is possible, but it seems a weak explanation when the similarities are as specific as they appear to be. To understand this controversy fully, we must also consider the provenance of the maps themselves. Piri Reis tells us that he used older sources, but he does not name them all. We know that knowledge was transmitted through the ages by copying and recopying maps, by sailors sharing charts, by scholars translating and compiling texts from different cultures. The ancient library of Alexandria, for example, was said to contain maps and geographical treatises from across the known world. When the library was destroyed, much of this knowledge was lost, but some of it may have survived in fragments, copied into Arabic, Greek, or Latin manuscripts, preserved in monasteries, private collections, and royal courts. It is possible, even likely, that medieval cartographers had access to scraps of information from much earlier periods, information they did not fully understand, but faithfully reproduced. This process of transmission is crucial. It means that a map drawn in the 16th century might contain data that is hundreds or even thousands of years older. The map is not evidence of what the cartographer knew, but of what his sources knew. And if those sources go back far enough, They might preserve knowledge from a time when the world looked very different, when coastlines were shaped by lower or higher sea levels, when ice covered less or more of the polar regions. This is the tantalizing possibility that keeps the mystery alive. Somewhere in the mists of prehistory, someone made these observations, recorded them, and passed them on. The maps we have today are echoes, faint and distorted perhaps, but echoes nonetheless. Now we turn to examine more closely the map that stands at the center of this controversy, the Piri Reis Map itself, and we do so not as casual observers, but as investigators seeking to understand what this artifact truly represents and what it can tell us about the knowledge of the ancient world. The transition from mystery to analysis is not a break in the story, but a deepening of it. For the more closely we look at the details, the more questions arise, and the more we are drawn into a labyrinth of evidence, speculation, and conflicting interpretations that have fascinated researchers for decades. The Piri Reis Map is not simply a historical curiosity. It is a challenge, a riddle written in ink and parchment, and to solve it, we must examine every line, every annotation, every feature that makes it so unusual and so controversial. The map was discovered in 1929 during renovations of the Topkapi Palace in Istanbul, the former residence of Ottoman sultans. It had been stored, forgotten, in the palace archives for centuries, its significance unrecognized until scholars began to study it in detail. The map is drawn on gazelle skin, a common medium for important documents in the Ottoman Empire, and it measures approximately 90 centimeters by 63 centimeters. Only about 1/3 of the original map survives. The rest has been lost to time, torn away or discarded, leaving us with a tantalizing fragment that shows the Atlantic Ocean, the western coast of Africa, the eastern coast of South America, and that mysterious southern landmass that has sparked so much debate. The map is beautifully illustrated, filled with ships, sea monsters, and detailed annotations in Turkish, written by Piri Reis himself to explain his sources and methods. What immediately strikes anyone who examines the Piri Reis Map is its level of detail. The coastline of South America is rendered with surprising accuracy, showing rivers, bays, and coastal features that match what we know from modern geography. The eastern bulge of Brazil is clearly visible, and the curvature of the coast follows the actual shape of the continent. This alone is remarkable, because in 1513, when Piri Reis created his map, European knowledge of South America was still limited. Columbus had made his voyages, Amerigo Vespucci had explored parts of the coast, but large sections remained unmapped and poorly understood. Yet here is Piri Reis, an Ottoman admiral working in Istanbul, producing a map that rivals or even exceeds the accuracy of contemporary European charts. How did he do it? His own notes provide part of the answer. He tells us that he consulted about 20 source maps, some of them very old, some captured from Spanish and Portuguese sailors, and some dating back to the time of Alexander the Great. Among these sources, he specifically mentions a map that had belonged to Christopher Columbus, a chart that Columbus himself reportedly used during his famous voyage of 1492. This reference to Columbus is significant, for it suggests that the great navigator did not sail blindly into the unknown, but had access to earlier maps, perhaps secret charts or fragments of ancient knowledge that hinted at lands across the Atlantic. We know that Columbus believed the world was smaller than it actually is, that he thought he could reach Asia by sailing west, and that he was surprised to find a vast continent blocking his way. But what if he also had access to older maps that showed the outline of the Americas, even if he did not fully understand what he was seeing? This possibility has intrigued historians for centuries. Some have argued that Columbus was privy to secret information, perhaps from Norse explorers who had reached North America centuries earlier, or from fishermen who had crossed the Atlantic and kept their discoveries quiet to protect their fishing grounds. The idea is not as far-fetched as it might seem. Knowledge was a valuable commodity in the age of exploration, and nations guarded their maps and charts jealously, keeping them locked away as state secrets. But the real controversy surrounding the Piri Reis Map centers not on South America, but on the southern landmass that extends from the bottom of the map, curving eastward in a way that suggests, to some researchers, the northern coast of Antarctica. This feature has been analyzed, debated, and reinterpreted countless times. Supporters of the ancient knowledge hypothesis argue that this landmass is indeed Antarctica, depicted as it would have appeared before it was covered by ice. They point to the shape, the orientation, and the coastal details, which they claim match the subglacial topography of Queen Maud Land and other parts of the Antarctic coast. To bolster their case, they cite a study conducted by the United States Air Force in 1960, in which cartographers compared the Piri Reis Map to modern seismic surveys of Antarctica. The report, written by Captain Lorenzo W. Burrows, suggested that the lower portion of the map did indeed resemble the coastline of Antarctica as it appears beneath the ice. This report has been quoted extensively by proponents of the lost civilization theory, who see it as official validation of their claims. However, skeptics have challenged this interpretation on multiple grounds. They argue that the resemblance between the map and Antarctica is superficial, the result of wishful thinking and selective interpretation. They point out that the southern landmass on the Piri Reis Map is connected to South America, whereas Antarctica is separated by the Drake Passage, a wide stretch of ocean. They also note that the scale and orientation of the landmass do not match Antarctica precisely. Some scholars have proposed an alternative explanation, one that is far more mundane, but also more consistent with the historical context. They suggest that the southern landmass is not Antarctica at all, but rather a continuation of the South American coast, distorted and exaggerated due to errors in projection and copying. According to this view, Piri Reis was attempting to depict the coast of Patagonia and perhaps the region around the Strait of Magellan, but because he was working from incomplete and inaccurate sources, he rendered it incorrectly, bending it eastward instead of southward. If you were to take the horizontal coastline at the bottom of the map and rotate it vertically, these critics argue, it would line up much more closely with the actual coast of South America, filling in gaps and matching features that are otherwise hard to explain. This debate over interpretation is not easily resolved because both sides can point to evidence that supports their view. The shape of the landmass does, in some respects, resemble the northern coast of Antarctica, particularly the region of Queen Maud Land. The bays, the inlets, the overall contour seem to echo what modern surveys have revealed. But at the same time, the landmass is too far north, too large, and too connected to South America to be a straightforward depiction of Antarctica. It is possible that what we are seeing is a hybrid, a mixture of real geographical knowledge and cartographic error, a landmass that combines elements of South America, speculative geography, and perhaps, just perhaps, fragments of older information about lands to the far south. The truth may lie somewhere in between the extremes, in a zone of ambiguity where ancient knowledge, medieval myth, and Renaissance exploration intersect in ways that are difficult to disentangle. To understand this better, we must consider how maps were made in the early 16th century. Cartography was not a precise science. It was an art, a craft, a process of compiling information from many sources, some reliable and some not, and trying to create a coherent picture of the world. Mapmakers relied on reports from sailors, travelers, and merchants, on astronomical observations, on older maps and texts, and on their own judgment and imagination. They copied and recopied maps, sometimes introducing errors, sometimes correcting them, sometimes embellishing them with decorative elements or speculative features. The process was cumulative and iterative, with knowledge building slowly over generations. A map like that of Piri Reis is therefore not a snapshot of what one person knew at one moment in time, but a synthesis of information gathered over centuries, filtered through multiple hands and minds, and subject to all the distortions and misunderstandings that such a process entails. One of the key challenges in early cartography was the problem of projection. The Earth is a sphere, but a map is flat, and there is no way to represent the surface of a sphere on a flat plane without some distortion. Different projection systems distort different features, some preserving shapes but distorting sizes, others preserving distances along certain lines but distorting angles. The Piri Reis Map does not use a modern projection system like the Mercator projection or the Winkel triple. Instead, it appears to use a kind of portolan chart projection, a method common in medieval Mediterranean cartography. Portolan charts were designed for navigation, and they depicted coastlines and harbors with great accuracy, but they did not account for the curvature of the Earth over long distances. As a result, portolan charts became increasingly distorted as they moved away from the Mediterranean and attempted to show larger regions. This could explain some of the oddities in the Piri Reis Map, the way South America seems to bend and stretch, the way the southern landmass curves eastward in a way that does not match any modern map. It is possible that Piri Reis was trying to fit together pieces of information from different sources, each using a different projection or scale, and that the result was a map that is accurate in parts but distorted overall. Yet even granting these difficulties, the Piri Reis Map remains impressive. The level of detail along the South American coast is striking, and many of the features shown are correct. The mouths of the Amazon River, the bulge of Brazil, the contours of the coastline, all are recognizable. This suggests that Piri Reis had access to good information that was based on actual exploration and observation. And if the southern landmass is not Antarctica, if it is simply a distorted version of South America, or a speculative Terra Australis, it is still remarkable that such a landmass appears on the map at all, in a position and with a shape that has caused so much debate and speculation. The map challenges us to think about what was known and what was unknown in the early 16th century, about the ways in which knowledge was transmitted and transformed, and about the possibility that some of this knowledge had roots in a much deeper past. To explore this possibility further, we must turn our attention to the other maps that have been drawn into this controversy, particularly the map of Orontius Finaeus from 1531. This map, like the Piri Reis Map, shows a large southern continent, but it does so with even more detail and with a shape that some researchers find even more compelling. The Orontius Finaeus map is a world map drawn on a heart-shaped projection, and at the bottom of the map, centered on the South Pole, is a continent labeled Terra Australis. This continent is not a vague outline or a speculative blob. It has rivers, mountains, coastal features, and a shape that, according to some analysts, corresponds remarkably well to the actual shape of Antarctica. The continent is shown as roughly circular, with a number of embayments and peninsulas, and its size is such that it covers the area where Antarctica is actually located. If you overlay the Orontius Finaeus map with a modern map of Antarctica, adjusting for scale and projection, there are striking similarities. The Ross Sea, the Weddell Sea, the Antarctic Peninsula, all seem to be represented, at least approximately. This has led some researchers to argue that the Orontius Finaeus map is even stronger evidence for ancient knowledge of Antarctica than the Piri Reis map. They point out that the map shows the continent in the correct position, at the correct scale, with features in the correct longitudes. If this is true, it would suggest that Orontius Finaeus had access to source maps of extraordinary accuracy, maps that could only have been created by a civilization with advanced surveying and navigational capabilities. But once again, skeptics have raised serious objections. They argue that the resemblance between the Orontius Finaeus map and Antarctica is exaggerated, that the map has been manipulated and distorted to make it fit. Some critics have shown that if you measure the continent on the Orontius Finaeus map, it is actually much larger than Antarctica, perhaps more than twice the size. To make it fit, you have to shrink it, rotate it, and adjust the coastlines, which undermines the claim that it is an accurate representation. Furthermore, they point out that Orontius Finaeus himself does not claim to have discovered a new continent. He labels it Terra Australis, the southern land, a concept that had been part of European geography for centuries. Ancient and medieval geographers believed that there must be a large land mass in the southern hemisphere to balance the continents of the north, and maps often depicted such a land mass, even though no one had ever seen it. The Orontius Finaeus map, according to this view, is simply another example of this tradition, a speculative continent drawn to fill in the blank spaces on the map. And yet, the question remains, why does the speculative continent look so much like Antarctica? If Orontius Finaeus was simply inventing a land mass, why did he give it rivers, mountains, and coastal details that seem to match, even approximately, the real geography of a continent that would not be discovered for another 3 centuries? Coincidence is always a possible explanation, but it is not always a satisfying one. It is worth noting that Orontius Finaeus was a respected mathematician and astronomer, a man of learning who had access to the best maps and geographical knowledge of his time. He was not a wild-eyed fantasist, but a serious scholar. If his map shows a southern continent with features that resemble Antarctica, it is at least worth asking whether he might have had access to older sources that contained information about the far south that has since been lost or forgotten. This brings us to one of the most fascinating and contentious aspects of the entire mystery: the question of how such maps could have been created at all, what technologies and methods would have been required, and whether those technologies existed in the ancient world or whether we must imagine something beyond what conventional history allows. The problem is fundamentally one of technique, of the practical means by which accurate geographical information is gathered, recorded, and transmitted. To appreciate the depth of this problem, we need to understand what it takes to make a map, not just a rough sketch or a symbolic representation, but a map that faithfully depicts the shapes of continents, the curves of coastlines, the positions of islands and bays with a degree of precision that can be verified against modern measurements. Such a map requires surveying, navigation, calculation, and a system of coordinates that allows locations to be fixed in space with mathematical rigor. The ancient world did possess sophisticated knowledge of mathematics, astronomy, and geography, far more than is sometimes appreciated. The Greeks, for example, understood that the Earth was a sphere, and they made remarkably accurate estimates of its size. Eratosthenes, a Greek scholar working in Alexandria in the 3rd century BC, calculated the circumference of the Earth by measuring the angle of the sun's rays at 2 different locations and using geometry to derive the distance. His result was astonishingly close to the true value, within a few percent. This shows that ancient scholars had the intellectual tools to understand the shape and size of the planet. They also developed systems of latitude and longitude, conceptual grids that could be used to locate places on the surface of the Earth. Ptolemy, the great geographer of the 2nd century AD, compiled a massive work called the Geography, in which he listed the coordinates of thousands of locations across the known world. His maps, based on these coordinates, were used and copied for centuries, influencing cartography well into the Renaissance. But there is a crucial difference between knowing the theory of latitude and longitude and being able to measure them accurately in practice. Latitude, as we have noted, is relatively easy to determine. It is simply the angle between the horizon and the sun or a star, and this angle can be measured with basic instruments like the gnomon, the astrolabe, or the quadrant. Ancient and medieval sailors used these devices to find their latitude at sea, and while the measurements were not perfect, they were good enough for navigation. Longitude, however, is a different matter entirely. It cannot be measured directly by observing the sky because the Earth rotates, and the position of the stars changes as you move east or west. To determine longitude, you need to know the time difference between your current location and a reference location, and to do that accurately, you need a clock that keeps precise time over long periods, even in the harsh conditions of a sea voyage. Such clocks did not exist until the 18th century, when John Harrison, an English clockmaker, invented the marine chronometer, a device that revolutionized navigation and finally solved the problem of longitude. Before Harrison, sailors used a variety of methods to estimate longitude, none of them very reliable. They could use dead reckoning, keeping track of their speed and direction, and calculating their position based on how far they had traveled. They could observe lunar eclipses or the positions of the moons of Jupiter, astronomical events that occurred at known times and could be used to determine the time difference between locations. But these methods were cumbersome, inaccurate, and impractical for routine navigation. The result was that most maps made before the 18th century had significant errors in longitude, with coastlines, islands, and continents placed in the wrong positions, sometimes by hundreds of miles. This is why the apparent accuracy of maps like those of Piri Reis and Orontius Finaeus is so puzzling. If European sailors in the 16th century could not reliably determine longitude, how could the creators of the source maps that Piri Reis and Orontius Finaeus consulted have done so? How could ancient or medieval navigators have charted the world with a precision that should have been beyond their reach? One possible answer, and it is the answer favored by proponents of the lost civilization theory, is that the ancient mapmakers did not use the methods we associate with traditional navigation. They suggest that a prehistoric culture, perhaps one that existed during or before the last ice age, developed technologies that we do not yet understand or that have left no trace in the archaeological record. These could have included advanced astronomical instruments, sophisticated surveying techniques, or even methods of long-distance communication that allowed observers at different locations to synchronize their measurements. Some have speculated that this lost civilization might have used a global grid system, a network of observation posts or markers that covered the Earth and provided a framework for map-making. Others have proposed that they had knowledge of the Earth's magnetic field and used it for navigation, or that they employed some form of celestial navigation far more advanced than anything known to later cultures. These ideas are, to put it mildly, speculative. There is no physical evidence for such technologies, no ruins, no artifacts, no written records that describe them. The archaeological record of human history during the Ice Age is sparse and fragmentary, but what we do have suggests that people at that time were hunter-gatherers, living in small groups, making stone tools, and surviving in a harsh and changing environment. There is no sign of cities, of writing, of metallurgy, of the kinds of complex social and technological infrastructure that would be required to support a global project of exploration and map-making. And yet, the absence of evidence is not the same as evidence of absence. It is possible, though unlikely, that such a civilization could have existed and left little or no trace, perhaps because it was destroyed by the cataclysmic changes at the end of the Ice Age, when sea levels rose, climates shifted, and entire landscapes were transformed or submerged. If such a civilization did exist, and if it had the knowledge and the means to chart the world, then the maps that have come down to us might indeed be fragments of that lost knowledge, echoes of a time when humanity had capabilities that we have since forgotten. A more conservative explanation, and one that many historians and cartographers favor, is that the apparent accuracy of the ancient maps is illusory, the result of errors, distortions, and coincidences that have been misinterpreted by modern researchers. According to this view, the southern land masses on the Piri Reis and Orontius Finaeus maps are not depictions of Antarctica, but rather speculative geographies, mythical continents that mapmakers invented to fill in the blank spaces on their charts. The idea of a terra australis, a great southern land, was deeply rooted in European thought, based on the belief that the Earth needed a counterbalance to the continents of the North. This belief persisted for centuries, and many maps showed a large continent in the southern hemisphere, even though no one had ever seen it. When Antarctica was finally discovered in the early 19th century, it was tempting to see it as the fulfillment of this ancient prophecy, and to imagine that earlier maps had somehow anticipated its existence. But in reality, the skeptics argue, the resemblance is superficial, the product of wishful thinking and selective interpretation. There is also the question of how information was transmitted from one generation to the next, from one culture to another, across vast stretches of time and space. We know that knowledge was preserved and passed down through copying, through translation, through oral tradition, and through the accumulated experience of sailors, travelers, and scholars. The great libraries of the ancient world, places like Alexandria, held vast collections of maps, texts, and documents from many different cultures, and these collections were consulted and copied by later scholars. When the Library of Alexandria was destroyed, much of this knowledge was lost, but some of it survived in fragments, in copies made before the destruction, in translations into Arabic, Syriac, or Latin, in the memories and writings of those who had studied there. It is entirely plausible that Piri Reis and Orontius Finaeus had access to maps that were copies of much older originals, maps that had been passed down through the centuries, each generation adding to them, correcting them, or distorting them in the process. The information on these maps might have come from many sources, from Phoenician sailors who explored the Atlantic, from Roman expeditions that ventured into the far north or south, from Arab navigators who crossed the Indian Ocean, from Norse explorers who reached North America. All of this knowledge could have been compiled, synthesized, and preserved in the form of maps, and fragments of it could have survived into the Renaissance, where it was incorporated into new maps by cartographers like Piri Reis and Orontius Finaeus. But this explanation, while plausible, still leaves us with difficult questions. If the information on the maps came from historical sources, from known cultures and explorers, why do we not have more direct evidence of their voyages? Why are there no written accounts, no archaeological remains, no clear traces of their presence in the places they supposedly explored? And why do the maps show features, like the subglacial coastline of Antarctica, that should not have been visible to any culture in recorded history? These are the questions that keep the mystery alive, that prevent it from being dismissed as simply a matter of coincidence or error. They force us to consider the possibility, however remote, that there is more to the story, that the maps are telling us something about the past that we have not yet fully understood. To probe deeper into this enigma, we must also consider the technical aspects of how the maps themselves were constructed, the methods of projection and representation that were used, and the ways in which these methods could have led to both accuracies and distortions. Mapmaking in the ancient and medieval world was not a uniform practice. Different cultures used different techniques, different conventions, different systems of measurement and representation. Mediterranean sailors, for example, used portolan charts, maps that showed coastlines, harbors, and navigational hazards with great detail and accuracy. These charts were designed for practical use at sea, and they were based on careful observation and measurement of distances and bearings. They did not use a formal system of latitude and longitude, but instead relied on a network of compass lines, called rhumb lines, that radiated from various points on the map and showed the directions a ship could sail. Portolan charts were remarkably accurate for the regions they covered, particularly the Mediterranean and the Atlantic coasts of Europe and Africa, but they became less reliable when extended over larger areas, because they did not account for the curvature of the Earth. Other map-making traditions used different approaches. Arab geographers, for example, drew on the legacy of Ptolemy and used systems of latitude and longitude, but they also incorporated information from their own explorations and from the accounts of travelers and merchants. Chinese cartographers developed their own methods, using grid systems and careful measurements to create maps of their empire and the surrounding regions. Each of these traditions had its strengths and weaknesses, its own conventions and distortions, and when maps from different traditions were combined or copied from one to another, the result could be a hybrid that mixed accurate information with errors and misunderstandings. This is likely what happened with maps like those of Piri Reis and Orontius Finaeus. They were compilations, syntheses of information from many sources, each with its own perspective and its own limitations. The challenge for modern researchers is to disentangle these sources, to identify what is accurate and what is not, and to understand how the information was transformed as it passed from hand to hand, from culture to culture, from century to century. One particularly striking example of this process of compilation and distortion can be found in the work of another Renaissance cartographer, Gerardus Mercator, whose name is now immortalized in the Mercator projection, the map system that has shaped our view of the world for centuries. Mercator was not only a map maker, but also a mathematician and a scholar, deeply versed in the geographical knowledge of his time, and he had access to a wide range of sources, both ancient and contemporary. In 1569, he published his famous World Map, a revolutionary work that used a new projection system designed to help sailors navigate by allowing them to plot courses as straight lines. But Mercator also created other maps, including a map of the Arctic regions that has attracted attention from those who study the mystery of ancient cartography. This map, published in 1595 and later updated by his successor Jodocus Hondius, shows the North Pole surrounded by a sea, with various islands and channels that some researchers claim correspond to features now hidden beneath the ice sheets of the Arctic Ocean and Greenland. The Mercator Arctic map is a curious document, filled with both real and imaginary features. At the center, Mercator depicted 4 large islands separated by channels that converge at the pole itself, and in the very center of the pole, he placed a massive black mountain, which he believed was made of magnetic rock, and explained why compass needles point north. This central mountain, the Rups Nigra as it was called, was pure myth, a legend drawn from medieval European lore, and it has no basis in reality. But surrounding this mythical core are depictions of coastlines, islands, and waterways that seem to show a more detailed knowledge of the Arctic than should have been available in the 16th century. Some of these features, when compared to modern maps of the Arctic made with sonar and radar, show intriguing similarities to the actual topography beneath the ice. The question, once again, is whether this is coincidence, whether it is the result of copying older maps that contained genuine information, or whether Mercator, like Piri Reis and Orontius Finaeus before him, was simply filling in blank spaces with educated guesses and speculative geography. What makes the Mercator Arctic map especially interesting is that it was created during a period of intense exploration and discovery, a time when European sailors were pushing into previously unknown waters, seeking new routes to Asia, new lands to claim, and new resources to exploit. The search for a northwest passage, a sea route through the Arctic that would connect the Atlantic and Pacific Oceans, was a major preoccupation of explorers in the 16th and 17th centuries. Many expeditions set out to find this passage, and many failed, their ships trapped in ice, their crews lost to the cold and starvation. Yet the dream persisted, fueled by reports and rumors of open water, of channels and straits that might lead through the frozen north. Mercator's map reflects this dream, showing the Arctic as a navigable sea rather than a solid mass of ice. In this respect, the map was both a product of contemporary exploration and a projection of hope and speculation, a vision of what the Arctic might be rather than what it actually was. But here is where the mystery deepens. Modern surveys of the Arctic, conducted with satellite imagery, ice-penetrating radar, and sonar, have revealed that beneath the ice there are indeed channels, valleys, and underwater features that match, at least in some cases, the depictions on Mercator's map. The Arctic Ocean is not a uniform expanse, but a complex landscape of ridges, trenches, and basins, shaped by millions of years of geological activity. Some of these features were islands or coastlines in the past, when sea levels were lower or when the ice cover was less extensive. Could Mercator have had access to information about these features, information that came from older sources, from explorers who had seen the Arctic during a warmer period, or from maps that depicted the region before the ice had fully formed? It is a tantalizing possibility, but it is also, many scholars insist, highly unlikely. The Arctic has been ice-covered for millions of years, and while there have been periods of relative warmth when the ice extent was reduced, there is no evidence that the Arctic was ever completely ice-free during the time of human civilization. Another map that has entered this debate is the Boache map, created in 1739 by Philippe Boache, a French geographer and cartographer who was one of the leading theoretical geographers of his time. The Boache map is unusual in that it shows Antarctica divided into 2 land masses, separated by a channel or strait that runs through the center of the continent. This depiction has fascinated researchers because modern surveys have revealed that Antarctica is indeed divided into 2 major regions, East Antarctica and West Antarctica, separated by a deep subglacial basin that lies below sea level. If the ice were removed, this basin would be filled with water, creating a channel much like the one shown on the Boache map. How could Boache have known this in 1739, decades before Antarctica was even discovered? Some argue that he had access to ancient maps that showed Antarctica as it appeared before the ice, and that he incorporated this information into his own work. Others suggest that Boache was simply theorizing, using his understanding of geography and symmetry to imagine what the southern continent might look like, and that the resemblance to the actual subglacial topography is coincidental. The debate over the Boache map is complicated by questions about its authenticity and its purpose. There are two versions of the map, one showing a speculative southern continent and another showing more detail, and some scholars have questioned whether the more detailed version is genuine or whether it might be a later fabrication. There is also the issue of what Boache's sources were and what he believed he was depicting. In the annotations on his map, Boache does not claim to be showing an ancient, ice-free Antarctica. Instead, he presents his map as a hypothesis, a theoretical construction based on the limited information available to him from contemporary explorers. He was trying to fill in the blank spaces on the map of the world, to imagine what lay in the uncharted southern regions, and his work reflects both the scientific thinking and the speculative spirit of the Enlightenment. Whether his map contains echoes of older knowledge, or whether it is simply an educated guess, remains an open question, one that cannot be definitively answered with the evidence we have. What all of these maps have in common, whether we are talking about the Piri Reis Map, the Orontius Finaeus Map, the Mercator Arctic Map, or the Boache Map, is that they challenge our assumptions about what was known and what was possible in the past. They force us to confront the limits of our own knowledge, to acknowledge that there are gaps in the historical record, periods and places about which we know very little, and to consider the possibility that some of what has been lost might have been more advanced, more extensive, or more surprising than we have imagined. This is not to say that we should accept every claim of ancient advanced civilizations or lost continents without skepticism. The burden of proof in such matters is high, and extraordinary claims require extraordinary evidence. But it is to say that we should approach these maps with an open mind, recognizing that they are complex documents, products of many hands and many sources, and that they may contain information that we do not yet fully understand. The process of analyzing these maps, of trying to determine what they show and where their information came from, is a painstaking and often frustrating task. It requires expertise in cartography, in the history of exploration, in geology and geophysics, in the methods and conventions of different map-making traditions. It also requires a willingness to look beyond the obvious, to consider alternative explanations, to question assumptions, and to follow the evidence wherever it leads. Some researchers have devoted years to studying these maps, measuring coastlines, comparing projections, analyzing annotations, and trying to trace the lineage of information from one map to another. Their work has produced a wealth of insights, but it has also revealed just how difficult it is to reach definitive conclusions. The maps are ambiguous, open to multiple interpretations, and the evidence they provide can be read in different ways depending on one's assumptions and perspective. One of the key challenges is the problem of distortion. All maps distort reality to some degree because they are two-dimensional representations of a three-dimensional world. Different projection systems distort different features, and when maps are copied from one projection to another, or when information from multiple sources is combined, the distortions can compound and create features that look like real geography, but are actually artifacts of the map-making process. This is especially true when dealing with polar regions, where the curvature of the Earth is most pronounced and where traditional projection systems break down. The Mercator projection, for example, greatly exaggerates the size of land near the poles, making Greenland appear as large as Africa, when in reality it is much smaller. Other projection systems compress or stretch the poles in different ways, and when these systems are mixed or misunderstood, the result can be maps that seem to show impossible or anachronistic features. Yet, despite all these complications, despite all the ways in which maps can mislead and confuse, there remains the tantalizing fact that some of these ancient and medieval maps do show features that we now know to be real, features that were hidden from view for centuries and only revealed by modern technology. This brings us to what is perhaps the most crucial piece of evidence in the entire controversy: the modern scientific surveys of Antarctica that have mapped the continent beneath its ice using techniques that were unimaginable until the second half of the 20th century. These surveys, conducted with seismic soundings, ice-penetrating radar, and satellite remote sensing have given us a view of Antarctica that no human had ever seen before, a view of the actual bedrock topography hidden under miles of ice, the true shape of the land that has been locked away from sight for millions of years. The story of how we came to map the subglacial topography of Antarctica is itself a remarkable chapter in the history of exploration and science. The first attempts to probe beneath the ice were made in the 1950s and 1960s during the International Geophysical Year, when scientists from many nations established research stations on the Antarctic continent and began systematic studies of the ice sheet. Early seismic surveys involved setting off explosions on the surface of the ice and measuring the time it took for the shock waves to travel down through the ice, reflect off the bedrock, and return to the surface. By analyzing these reflections, scientists could calculate the thickness of the ice and determine the elevation of the bedrock beneath. The process was laborious and slow, requiring teams of researchers to haul heavy equipment across the ice, drill holes, set charges, and record data by hand. But gradually, point by point, a picture began to emerge of the hidden landscape beneath the Antarctic ice, a landscape of mountains, valleys, basins, and plateaus, shaped by millions of years of geological processes and completely invisible to the human eye. In the decades that followed, the technology improved dramatically. Ice-penetrating radar, a technique that uses radio waves instead of seismic waves to probe the ice, made it possible to survey large areas much more quickly and efficiently. Aircraft equipped with radar systems could fly over the ice sheet, continuously transmitting radio signals downward and recording the echoes that bounced back from the bedrock. The data could be processed to create detailed maps showing not only the thickness of the ice, but also the contours of the land beneath. By the 1970s and 1980s, extensive radar surveys had been conducted over much of Antarctica, and the results were compiled into maps that showed, for the first time, the true topography of the continent. These maps revealed a world of stunning complexity, a landscape far more varied and rugged than anyone had imagined. There were mountain ranges as high as the Alps, buried completely under ice, vast plains that lay below sea level, deep trenches and rifts, and a coastline that, without the ice, would have a very different shape from the one we see today. One of the most significant discoveries was that Antarctica is not a single continuous landmass, but is divided into two distinct regions, East Antarctica and West Antarctica, separated by a great rift valley called the Trans-Antarctic Mountains. East Antarctica is a high plateau underlain by ancient rock that has remained stable for hundreds of millions of years. West Antarctica, by contrast, is a lower and more complex region with much of its bedrock lying below sea level. If the ice were removed, West Antarctica would not be a single continent, but an archipelago of islands, separated by channels of water. This discovery has profound implications for understanding the history and future of the Antarctic ice sheet, because it means that parts of the ice sheet are resting on bedrock that is below sea level, and are therefore potentially vulnerable to collapse if the climate warms and the ice begins to melt. But for our purposes, the most interesting aspect of these subglacial maps is the way they have reignited the debate over the ancient maps of Antarctica. When researchers compared the coastline of Antarctica, as depicted on the Piri Reis Map, and the Orontius Finaeus map with the subglacial topography revealed by modern surveys, they found some striking similarities, particularly along the coast of Queen Maud Land, the region of East Antarctica that faces the Atlantic Ocean. The subglacial coastline of Queen Maud Land, the line where the bedrock meets the sea beneath the ice, has a series of bays, peninsulas, and embayments that, according to some analysts, correspond to features shown on the Piri Reis Map. The correlation is not perfect, and it depends on how you interpret the projection and scale of the old map, but it is close enough to be intriguing. If the Piri Reis Map really does show the subglacial coastline of Antarctica, then it would mean that the map was based on information gathered at a time when the ice was not there, or at least not as extensive as it is today, and that would push the origin of the map back thousands of years, to a time long before any known civilization had the technology to conduct such surveys. This is where the controversy becomes most intense, because the implications are so profound. For Antarctica to be ice-free, or even partially ice-free, we would have to go back to a period before the current ice age began, and geological evidence suggests that the Antarctic ice sheet has been in place, in some form, for at least 30 million years. There have been fluctuations in the extent of the ice, periods when it was larger and periods when it was smaller, but the continent has not been completely free of ice within the time frame of human history. The only way the Piri Reis Map could show an ice-free Antarctica is if it was based on information that is millions of years old, which is clearly impossible, or if the ice extent was much less during a relatively recent warm period, which is not supported by the current scientific consensus. And yet, the similarities between the map and the subglacial topography remain, defying easy explanation and continuing to fuel speculation about lost civilizations, ancient knowledge, and the limits of what we think we know about the past. Some researchers have tried to resolve this puzzle by proposing that the ice extent in Antarctica has varied more dramatically than mainstream science acknowledges, that there may have been brief periods during the last 10 or 20,000 years when parts of the Antarctic coast were ice-free and accessible to human exploration. They point to evidence of rapid climate change at the end of the last ice age, when global temperatures rose, sea levels increased by more than 100 meters, and ice sheets in the northern hemisphere melted away within a few thousand years. Could something similar have happened in Antarctica? A brief warm period that exposed parts of the coast before the ice returned? The problem with this hypothesis is that there is very little evidence to support it. Ice cores drilled from the Antarctic ice sheet, which provide a detailed record of past climate conditions going back hundreds of thousands of years, do not show any period of dramatic warming that would have been sufficient to melt away large portions of the ice. The Antarctic climate has been relatively stable compared to the wild swings seen in the northern hemisphere, and while there have been fluctuations, they have not been of the magnitude required to expose the coast. Another approach has been to re-examine the maps themselves, to look more carefully at what they actually show, and to consider alternative interpretations that do not require an ice-free Antarctica. Some scholars have argued that the southern landmass on the Piri Reis Map is not Antarctica at all, but rather an extension or distortion of the South American coast, or a speculative continent drawn to fill in the unknown regions of the map. They suggest that the resemblance to Antarctica is coincidental, the result of the way the map was projected, and the way we, with the benefit of hindsight, are interpreting features that were meant to represent something else. This interpretation is more conservative and fits better with what we know about the history of cartography and exploration, but it also requires us to dismiss the correlations that some researchers have found to explain them away as wishful thinking or selective interpretation. The debate, in other words, comes down to a question of how we weigh the evidence, how much credence we give to the apparent similarities, and whether we are willing to entertain the possibility that something extraordinary might have occurred in the distant past. What makes this debate so difficult to resolve is that the evidence is incomplete and ambiguous. The maps themselves are fragmentary, damaged, and open to multiple interpretations. The annotations and notes left by the cartographers are often vague or contradictory, and the sources they cite are lost or unknown. The geological and climatological evidence from Antarctica is extensive, but not exhaustive, and there are still gaps in our understanding of the continent's history, particularly during the critical period at the end of the last ice age, when the global climate was undergoing rapid and dramatic changes. In the absence of definitive proof, the mystery of the Ice Age mapmakers remains just that, a mystery, a puzzle that continues to intrigue and frustrate researchers from many different fields. Yet as we grapple with these uncertainties, we must also confront the larger question that lies at the heart of this entire investigation, the question of whether it is even possible for an advanced civilization to have existed in the distant past, a civilization capable of exploring the world, mapping its coastlines, and leaving behind knowledge that would survive in fragmentary form for thousands of years. This is not merely a question of cartography or geology, but a question about the nature of human history itself, about the assumptions we make regarding the trajectory of civilization, and about whether the conventional narrative of slow, steady progress from primitive beginnings to modern complexity is the only possible story, or whether there might be chapters we have missed, periods of development and decline that have left little trace in the archaeological record. To explore this possibility, we must step back from the maps themselves and examine the broader context of what we know and what we do not know about the ancient world. The standard view of human history, the one taught in schools and universities, holds that civilization began relatively recently, within the last 10,000 years or so, following the end of the last ice age. Before that, humans lived as nomadic hunter-gatherers, following herds of animals, gathering wild plants, and surviving in small, mobile groups. Then, around 12,000 years ago, something changed. The climate warmed, the great ice sheets melted, and in certain favorable regions, particularly in the Middle East, people began to settle down, to cultivate crops, to domesticate animals, and to build permanent villages. This was the Neolithic Revolution, the dawn of agriculture, and it set the stage for everything that followed. With farming came surplus food, and with surplus food came population growth, social stratification, specialization of labor, and eventually the rise of cities, states, and empires. The first great civilizations, Sumer in Mesopotamia, ancient Egypt along the Nile, the Indus Valley civilization in what is now Pakistan, emerged around 5,000 years ago, and from there the story unfolds in a more or less continuous line through the Bronze Age, the Iron Age, Classical Antiquity, the Middle Ages, and into the modern era. This narrative is compelling, and it is supported by a vast body of archaeological, linguistic, and genetic evidence. But it is also, in some respects, a simplified and incomplete story. There are gaps in the record, periods and places about which we know very little, and there are anomalies, finds, and features that do not fit neatly into the standard timeline. Some of these anomalies have fueled speculation about lost civilizations, about cultures that rose and fell before the ones we know about, leaving behind only scattered traces. The idea of a lost, advanced civilization is not new. It has been part of human mythology and literature for thousands of years, from Plato's account of Atlantis to legends of sunken cities and forgotten empires found in cultures around the world. But until recently, these ideas were largely dismissed by mainstream archaeology as myth, as fantasy, as the product of imagination rather than evidence. However, in the last few decades, new discoveries and new ways of thinking have begun to challenge some of the assumptions underlying the conventional narrative. One of the key insights has come from the realization that sea level rise at the end of the Ice Age was far more dramatic and far more consequential than previously understood. Between roughly 20,000 years ago and 7,000 years ago, global sea levels rose by more than 120 meters, inundating vast areas of coastal land and transforming the geography of the planet. During the Ice Age, when much of the world's water was locked up in ice sheets, sea levels were much lower, and what is now the ocean floor was dry land. This included large areas that would have been highly favorable for human habitation, regions with fertile soil, abundant resources, and moderate climates. The coastlines of the Ice Age world were not where they are today. They were hundreds of kilometers farther out, and they would have been among the most attractive places for people to live. Yet today, these landscapes are underwater, buried beneath hundreds of feet of ocean, and largely inaccessible to archaeological investigation. This has profound implications for our understanding of prehistory. If the most favorable and most heavily populated areas of the Ice Age world are now submerged, then much of the evidence for what people were doing during that period has been lost or hidden from view. We are, in effect, looking at only part of the picture, the inland areas that remained above water, which may not have been the centers of population or innovation. It is as if future archaeologists, trying to reconstruct our own civilization after some cataclysm, could only excavate the mountain regions and had no access to the great coastal cities where most people live today. Their picture of our world would be skewed, incomplete, and in some respects, fundamentally wrong. The same may be true of our picture of the Ice Age world. The coastal settlements, the ports, the trade networks, the places where people gathered and exchanged ideas, may all be underwater, and until we can systematically explore and excavate these submerged landscapes, our understanding of what was happening during that period will remain partial and uncertain. Some researchers have begun to explore these submerged landscapes using underwater archaeology, sonar mapping, and other techniques, and they have found tantalizing hints of human activity in places that are now deep beneath the sea. Off the coast of India, for example, there are underwater structures that some believe may be the remains of ancient settlements, though this is hotly debated. In the Mediterranean, underwater archaeologists have discovered entire cities, ports, and harbors that were submerged by rising sea levels or by geological events like earthquakes and subsidence. These finds demonstrate that significant human activity did take place in areas that are now underwater, and they raise the question of what else might be down there, waiting to be discovered. If there were advanced cultures living along the coasts of the Ice Age world, cultures that developed seafaring, trade, and perhaps even rudimentary forms of science and technology, their remains would be in the last places we have looked beneath the waves, and we would have little direct evidence of their existence until we go looking for it in the right places. This brings us back to the question of the maps. If there were maritime cultures during or before the end of the Ice Age, cultures that explored widely and accumulated geographical knowledge, they might have created maps or other records of their explorations. These records could have been preserved in some form, passed down through oral tradition, copied onto more durable materials, or incorporated into the myths and legends of later cultures. When the ice melted and the seas rose, these cultures would have been devastated, their coastal settlements flooded, their populations displaced, and their knowledge scattered. But fragments might have survived, carried inland by refugees, incorporated into the lore of the people who came after, and eventually finding their way onto the maps that we have been examining. This is, admittedly, a speculative scenario, but it is one that fits some of the evidence, and that does not require us to invoke impossible technologies or supernatural explanations. It simply requires us to acknowledge that human beings 12,000 years ago may have been more capable, more innovative, and more widespread than we have given them credit for. The challenge is that we have very little direct evidence for such a scenario. The archaeological record from the late Ice Age is sparse, and most of what we have comes from inland sites, caves, and rock shelters where organic materials have been preserved. We have stone tools, bone implements, art, and burials that give us glimpses into the lives of Ice Age people, but we have very little evidence of their maritime activities, of boats, navigation, or long-distance trade. Part of this is due to preservation bias. Wood, leather, fiber, and other materials used to make boats and sails do not survive for thousands of years unless they are in very special conditions, like frozen ground or waterlogged peat bogs. The boats of Ice Age people, if they existed, would have rotted away long ago, leaving no trace. Similarly, if there were ports, docks, or coastal settlements, they are now underwater, and we have only just begun to search for them systematically. However, there is another piece of this puzzle that we must consider, one that shifts the focus from the question of whether an advanced civilization could have existed to the question of what traces such a civilization might have left behind, and whether those traces could have survived long enough to influence later cultures and appear on maps centuries or millennia after the original knowledge was created. This is where the debate moves from the realm of pure speculation into something more grounded, more tangible, though no less controversial. We must examine the archaeological evidence, the hints and anomalies that suggest human activity in unexpected places or at unexpected times, and we must consider how knowledge, once gained, can be preserved and transmitted even when the civilization that created it has vanished from the earth. The archaeological record is, by its nature, incomplete and biased toward certain types of preservation. Stone structures, pottery, metal objects, these survive for thousands of years and can be excavated and studied. But organic materials, wood, cloth, leather, paper, these decay rapidly except in very special conditions. A civilization that built primarily in wood, that used organic materials for its technology, that lived along coastlines now underwater, would leave very little trace in the archaeological record. Most of what they created would have rotted away, been washed away, or been buried under sediments or rising seas. This is why the absence of evidence for a lost civilization is not necessarily evidence of its absence. It may simply mean that we are looking in the wrong places, or that the evidence has not survived in a form we can recognize. There are, however, certain anomalies in the archaeological and geological record that have attracted attention from those who believe in the possibility of lost civilizations. Some of these anomalies are geological formations that appear to show signs of human modification, structures that are too regular, too symmetrical, or too precisely aligned to be purely natural. Others are artifacts, objects that seem out of place in the layers of rock or sediment where they are found, suggesting either that they are much older than they should be, or that they were moved by natural processes from their original context. Still others are patterns of human settlement and migration that do not fit neatly into the conventional timeline, suggesting that people were moving around the world, crossing oceans, and establishing contact between distant regions much earlier than mainstream archaeology acknowledges. One example that is often cited is the presence of similar architectural styles, artistic motifs, and mythological themes in widely separated cultures that are not supposed to have had contact with each other. The pyramids of Egypt and the pyramids of Mesoamerica, for instance, are separated by thousands of miles and thousands of years, yet they share a common form, a stepped or smooth-sided pyramid structure that served as a religious monument and a symbol of power. Is this convergent evolution, the idea that different cultures independently arrived at the same solution to the same architectural problem, or is it evidence of a shared cultural heritage, a common source of knowledge that both cultures inherited from an earlier civilization? The debate is ongoing, and there is no consensus. Mainstream archaeology favors the convergent evolution explanation, noting that pyramids are a stable and impressive structure that can be built with simple tools and labor, and that the specific details of Egyptian and Mesoamerican pyramids are quite different, suggesting independent development. But some researchers point to other similarities, in mythology, in symbolism, in astronomical alignments, that they believe are too specific to be coincidental. Another example is the myth of a great flood that appears in the traditions of cultures around the world. The story of Noah's Ark in the Bible, the Epic of Gilgamesh from Mesopotamia, the flood myths of indigenous peoples in the Americas, Australia, and Asia all describe a cataclysmic deluge that destroyed the world and forced humanity to start over. Some researchers have suggested that these myths are not purely symbolic or religious, but are based on actual historical events, specifically the rapid sea level rise at the end of the Ice Age, which would have flooded coastal settlements and forced people to flee inland. If this is true, then the flood myths may be a form of cultural memory, a way of preserving and transmitting knowledge of a catastrophic event that occurred thousands of years ago. And if these myths are based on real events, then perhaps other myths, legends of lost continents, sunken cities, and advanced civilizations also have a basis in historical reality. The challenge is to separate myth from history, to determine which stories are purely symbolic and which contain kernels of truth. This is not easy, because myths are by their nature ambiguous, open to multiple interpretations, and often changed and embellished over time. But archaeologists and historians have developed methods for analyzing myths and comparing them to the physical evidence, looking for correlations and testing hypotheses. In some cases, myths have led to real discoveries. The city of Troy, for example, was long thought to be purely legendary, a fictional setting for Homer's Iliad, until the archaeologist Heinrich Schliemann excavated the site in the late 19th century and proved that Troy was a real place. Similarly, the Minoan civilization of Crete, which some believe may have inspired the legend of Atlantis, was unknown to modern scholars until the early 20th century, when Sir Arthur Evans excavated the palace at Knossos and revealed a sophisticated Bronze Age culture that had been forgotten for thousands of years. Could the same be true of the Mapmakers of the Ice Age? Could there be a lost civilization, a maritime culture that explored the world, accumulated geographical knowledge, and then vanished, leaving behind only fragments of its maps and echoes in the myths and legends of later peoples? The evidence is tantalizing but inconclusive. The maps themselves are ambiguous, open to multiple interpretations. The geological evidence from Antarctica shows that the continent has been ice-covered for millions of years, but there are uncertainties about the exact extent of the ice during warmer periods. The archaeological evidence for advanced maritime activity during the Ice Age is sparse, but this may be because the relevant sites are now underwater and have not been systematically explored. The myths and legends of ancient floods and lost lands are widespread, but they can be interpreted in many ways, and it is difficult to know which parts, if any, are based on historical events. What is clear is that the end of the Ice Age was a time of profound change, a period when the world as it had been for tens of thousands of years was transformed almost beyond recognition. The great ice sheets melted, sea levels rose, climates shifted, entire ecosystems were rearranged, and human populations were forced to adapt or perish. In some regions, this transformation was relatively gradual, taking place over centuries or millennia, giving people time to adjust. In other regions, the changes were more rapid and more catastrophic. There is evidence of sudden floods, massive outbursts of water from glacial lakes that had been held back by ice dams, which then collapsed and released torrents that carved deep valleys and inundated lowlands in a matter of days or weeks. There is evidence of tsunamis triggered by underwater landslides or by the collapse of ice shelves into the sea. There is evidence of volcanic eruptions and earthquakes associated with the shifting weight of ice and the rebound of the Earth's crust as the ice melted. All of these events would have been traumatic for the people who experienced them, and they would have left lasting impressions, memories that were passed down in the form of stories, myths, and perhaps maps. If there were coastal civilizations during the Ice Age, cultures that had developed seafaring, trade, and a degree of technological sophistication, they would have been particularly vulnerable to the rising seas. Their settlements, their ports, their centers of learning and commerce would have been on the coasts, in the very places that were first to be inundated. As the seas rose, these cultures would have been forced to retreat inland, to abandon their homes, to migrate to higher ground. In the process, much of their material culture would have been lost, submerged beneath the waves or buried under sediments. But their knowledge, their skills, their traditions could have been preserved by the survivors, carried with them to new lands, and passed down to future generations. Over time, as the memory of the original civilization faded, this knowledge might have become fragmented, distorted, mixed with new information and new myths, until it was no longer clear where it came from or what it represented. But fragments might have survived, copied from map to map, from generation to generation, until they appeared on the parchments of Renaissance cartographers who had no idea of their true age or origin. This brings us to a crucial stage in the debate, the collision of interpretation and hard evidence, and the challenge of dissecting the claims made about maps such as those of Piri Reis and Orontius Finaeus. The transition is not abrupt. It is the gradual sharpening of inquiry that follows the investigation of lost knowledge and submerged civilizations. Now, the question becomes, what is the real foundation behind these famous maps, and what do modern experts say about their origins and unusual features? Scholars have analyzed the Piri Reis Map in detail, noting that while some visual similarities between its southern landmass and the Antarctic coast exist, there is no direct textual or historical evidence showing that the map was intended to depict an ice-free Antarctica. Much of the southern region on Piri Reis's chart remains unidentified, with some authors interpreting it as mythic or speculative land, and others pointing to influences from contemporary Portuguese geographic theories, not true Antarctic features. Several researchers suggest the map's details mostly stem from knowledge of South America, integrated with legendary or hypothetical land to complete the old tradition of Terra Australis, rather than actual cartographic evidence for early Antarctic exploration. Likewise, the Orontius Finaeus map has sparked debate due to its portrayal of a detailed southern continent resembling Antarctica. Some theorists argue that these maps record accurate pre-Ice Age topography, possibly dating back 15,000 years or more. They claim that the geometrical accuracy, especially the correlation of map longitudes, is difficult to explain through known Renaissance technologies, as accurate longitudes demand advanced timekeeping. However, mainstream historians and cartographers point out that these Renaissance maps routinely synthesized fragments from portolans, globes, and planispheres, joining together newly discovered coastlines, such as Tierra del Fuego, with speculative geography and myth. Many critical analyses argue that errors and creative extrapolation, rather than preserved ancient science, most likely account for the similarities between these maps and Antarctica's current or former outline. Some evidence exists for fragments of older geographical knowledge passing down across generations, with cartographers compiling charts from earlier, sometimes mysterious, sources. Maps such as those of Piri Reis and Finaeus indeed showcase some surprising accuracy for South American coasts, but their more controversial parts are not reliably supported by archaeological, geological, or textual evidence. Claims about seismic matches with Antarctica's subglacial coastline have arisen, especially following a 1960s U.S. Hydrographic Office review, yet subsequent analysis shows that these comparisons were mostly eyeballed rather than rigorously quantified, and modern computer techniques do not uphold the striking matches once implied. Attribution of lost Phoenician, Egyptian, or even Atlantean origins for these maps thus remain highly speculative, with the lack of corresponding written records or artifacts being a persistent challenge. In sum, while the intrigue surrounding these ancient maps has inspired many to believe in lost civilizations and forgotten knowledge, the bulk of scholarly interpretation today leans toward viewing them as products of creative synthesis assembled from contemporary discoveries, rumors, previous charts, and mythic traditions. Their real fascination lies not in proving the existence of an advanced Ice Age civilization, but in reminding us how knowledge can be preserved, transformed, and mythologized across generations, creating documents that challenge our understanding and fuel further curiosity. This collision between belief and evidence brings us to what is perhaps the most significant and revealing aspect of the entire mystery: the need to confront the contradictions directly, to weigh the arguments of both proponents and skeptics with equal rigor, and to understand what the debate over these ancient maps tells us not just about the past, but about how we construct and evaluate historical narratives. The transition from speculative wonder to critical analysis is essential, for it is in this space, between fascination and skepticism, that we find the truth, or at least approach it as closely as the evidence allows. When Charles Hapgood, a professor of the history of science at Keene College, first published his groundbreaking book Maps of the Ancient Sea Kings in 1966, he ignited a firestorm of controversy that has not subsided to this day. Hapgood's central thesis was that the Piri Reis Map, the Orontius Finaeus Map, and several other medieval and Renaissance charts were not original works, but copies of much older source maps, maps that had been created by an advanced maritime civilization that existed during or before the last Ice Age. According to Hapgood, these ancient mapmakers possessed a level of geographical knowledge and technical skill that would not be matched again until the 18th century or later. They had explored the entire world, including Antarctica, at a time when the continent was either ice-free or less heavily glaciated than it is today. They had developed accurate methods for determining longitude, they had created maps using sophisticated projection systems, and they had passed this knowledge down through the centuries until fragments of it appeared on the maps of Piri Reis, Orontius Finaeus, and others. To support his claims, Hapgood marshaled what he believed was compelling evidence. He noted that the Piri Reis map showed features of the South American coastline with remarkable accuracy for a map created in 1513, when European knowledge of the region was still limited. He argued that the southern landmass on the map corresponded to the coast of Queen Maud Land in Antarctica, not as it appears today under ice, but as it would look if the ice were removed. To bolster this claim, he contacted the United States Air Force and requested information about seismic surveys that had been conducted in Antarctica. In 1960, he received a letter from Lieutenant Colonel Harold Z. Ohlmeyer, who had been involved in mapping the Antarctic using ice-penetrating seismic techniques. Ohlmeyer's letter, which Hapgood quoted extensively in his book, stated that the lower portion of the Piri Reis Map portrayed the Princess Martha coast of Queen Maud Land, and that this was the most logical interpretation of the map. He further suggested that the geographical detail shown on the map agreed very remarkably with the seismic profile of the subglacial topography. This letter became a cornerstone of Hapgood's argument and has been cited repeatedly by those who believe in the ancient Antarctica hypothesis. However, closer examination of Ohlmeyer's letter and the methods he used reveals significant problems. Ohlmeyer did not conduct a rigorous quantitative comparison of the Piri Reis map with the seismic data. Instead, he appears to have made a visual qualitative assessment, essentially eyeballing the similarities between the two. This kind of comparison is notoriously unreliable because the human brain is exceptionally good at finding patterns and resemblances even when they are not there, a phenomenon known as pareidolia. When later researchers attempted to replicate Ohlmeyer's analysis using more precise methods, including computer-aided comparisons and careful measurements of scales, projections, and coastline features, they found that the supposed match between the Piri Reis map and the Antarctic coast was far less convincing than Hapgood had claimed. The Orontius Finaeus map presented similar problems. At first glance, the map does appear to show a continent in the position of Antarctica, with a roughly circular shape, rivers, mountains, and coastal features that seem to correspond at least approximately to the real geography of the continent. Hapgood and his followers argued that this could not be coincidence, that the map must have been based on ancient source maps created when Antarctica was ice-free. However, detailed analysis has revealed numerous inconsistencies and inaccuracies that undermine this interpretation. The continent shown on the Orontius Finaeus map is significantly larger than the actual Antarctica, in some estimates more than twice the size. Its orientation is incorrect, rotated by several degrees compared to the real continent. The Antarctic Peninsula, one of the most prominent features of the real Antarctica, is completely absent from the map, or at least not recognizable in any of the coastal features shown. Many of the rivers, bays, and mountains depicted on the map do not correspond to any known features of the actual Antarctic topography, either as it appears on the surface or as it has been revealed by surveys of the bedrock beneath the ice. Critics have pointed out that these discrepancies are not minor errors that could be attributed to the imperfections of ancient map-making techniques. They are fundamental mismatches that suggest the map was not based on accurate surveys of Antarctica at all, but rather on speculation, imagination, and the long-standing cartographic tradition of depicting a terra australis, a great southern land, to balance the known continents of the northern hemisphere. This tradition goes back to ancient Greek geography, particularly to the work of Ptolemy, who theorized that there must be large land masses in the southern hemisphere to counterbalance the weight of the northern continents and maintain the Earth's equilibrium. Medieval and Renaissance mapmakers inherited this idea, and many of them drew speculative southern continents on their maps, even though no European had ever seen them. The Orontius Finaeus map, according to this interpretation, is simply another example of this tradition, a cartographic fantasy rather than a record of real exploration. Furthermore, critics have noted that Hapgood's analysis was inconsistent and selective. On the one hand, he emphasized the supposed accuracy of certain features of the maps, arguing that they could only have come from precise surveys conducted with advanced technology. On the other hand, when confronted with obvious errors and discrepancies, he explained them away by proposing that the ancient source maps had been compiled from multiple local maps created at different times and in different places, and that errors had been introduced during the process of copying and compilation. This kind of ad hoc reasoning, critics argue, allows Hapgood to have it both ways, claiming accuracy when it suits his thesis and dismissing inaccuracy as a product of later corruption. A more parsimonious explanation, they suggest, is that the maps are exactly what they appear to be: Renaissance-era compilations based on contemporary exploration, older medieval maps, classical geographical theories, and a good deal of speculation to fill in the unknown regions. One of the most devastating critiques of Hapgood's hypothesis came from geologists and glaciologists who examined his claims about Antarctica's ice cover. Hapgood argued that the maps showed Antarctica as it appeared during a warm period when the ice had retreated or disappeared, and he suggested that this must have been relatively recent, within the last 15,000 years or so. Otherwise, the maps could not have been created by human mapmakers. However, the geological evidence tells a very different story. Ice cores drilled from the Antarctic ice sheet provide a continuous climate record going back hundreds of thousands of years, and they show that the continent has been ice-covered throughout this entire period, with no significant warm intervals that would have melted away the ice. The Antarctic ice sheet is ancient, dating back at least 30 million years, and while its extent has fluctuated in response to climate changes, it has never completely disappeared during the time of human existence. For Antarctica to be ice-free, we would have to go back millions of years, long before humans or even hominids existed. Some proponents of the ancient maps hypothesis have tried to get around this problem by suggesting that the maps do not show a completely ice-free Antarctica, but rather one in which the ice was less extensive, perhaps retreating to the interior and leaving the coasts exposed. However, this scenario is also not supported by the evidence. The Antarctic ice sheet is fed by snowfall that accumulates in the interior and flows outward toward the coasts, where it forms ice shelves that extend over the ocean. For the coasts to be ice-free while the interior remains glaciated is physically implausible, because the ice would continue to flow outward and cover the coasts unless the climate was warm enough to melt it at the margins, which would also cause melting in the interior. Furthermore, seismic and radar surveys of the subglacial topography show that much of West Antarctica lies below sea level, and if the ice were removed without isostatic rebound, the slow rising of the land after the weight of the ice is lifted, these regions would be flooded, creating an archipelago rather than a single continent. None of the ancient maps show Antarctica in this configuration. Another line of criticism focuses on the issue of longitude. Hapgood argued that the accuracy of the ancient maps, particularly with regard to the east-west positioning of coastlines and islands, indicated that the mapmakers had a method for determining longitude that was as good as or better than anything available in Europe until the invention of the marine chronometer in the 18th century. However, modern analysis of the Piri Reis and Orontius Finaeus maps shows that their longitudinal accuracy is far from perfect. There are significant errors in the placement of features, with some coastlines and islands shifted by hundreds of kilometers from their true positions. These errors are consistent with the limitations of Renaissance-era cartography, which relied on dead reckoning and rough estimates rather than precise measurements. If the maps had been based on ancient source maps created with advanced technology, we would expect the longitudinal errors to be much smaller, and we would expect them to be random rather than systematic. Instead, the errors show the characteristic patterns of pre-chronometer navigation. Despite all of these critiques, the mystery of the ancient maps has not been entirely laid to rest. There remain features of the Piri Reis Map and other charts that are difficult to explain within the conventional framework of Renaissance cartography. The level of detail shown for certain parts of the South American coast, the apparent knowledge of features that had not yet been fully explored by Europeans, the tantalizing similarities between the map's southern landmass and the Antarctic coast, all continue to provoke questions and debate. Some researchers have proposed middle ground explanations, suggesting that the maps might incorporate fragments of pre-Columbian exploration, perhaps by Polynesian navigators, African sailors, or even Vikings who had reached the New World centuries before Columbus. Others have argued that the maps reflect a more sophisticated exchange of geographical knowledge than is usually acknowledged, with information flowing between different maritime cultures, Portuguese, Arab, Chinese, Indian, and being compiled into composite maps that drew on multiple traditions. What the debate ultimately reveals is not so much a definitive answer to the question of whether the maps show ancient knowledge of Antarctica, but rather a deeper insight into the nature of cartographic history and the ways in which geographical knowledge is created, transmitted, and transformed over time. Maps are not neutral, objective documents. They are products of their time, shaped by the technological capabilities, cultural beliefs, political interests, and imaginative visions of their creators. They combine observation with speculation, accuracy with error, fact with myth. Understanding them requires not just measuring coastlines and comparing projections, but also interpreting the intentions and contexts of the mapmakers, the sources they used, the audiences they addressed, and the purposes they served. The Piri Reis Map, the Orontius Finaeus Map, and the other charts at the center of this controversy are fascinating precisely because they are ambiguous, because they sit at the intersection of knowledge and imagination, exploration and speculation, history and legend. And so we arrive at the end of this long journey through the enigma of the Ice Age mapmakers, having traversed centuries of cartographic history, examined maps that challenge our understanding of the past, weighed the arguments of believers and skeptics, and confronted the fundamental questions about what we know and what we can know about ancient civilizations. The journey has been winding, filled with tantalizing clues and frustrating dead ends, with moments of revelation and moments of doubt. Now, as we prepare to close this investigation, we must ask ourselves what the mystery of these ancient maps ultimately means, what lessons it holds for our understanding of history, and what questions remain for future explorers and scholars to pursue. The debate over the Piri Reis Map, the Orontius Finaeus Map, and the other charts we have examined is not simply an academic dispute about the accuracy of old documents. It is a debate about the nature of human achievement, about the trajectory of civilization, about whether our species has followed a single, linear path from primitive origins to modern complexity, or whether there have been detours, branches, rises, and falls that we have not yet fully recognized. The maps stand as symbols of this larger question, artifacts that seem to whisper of knowledge that should not exist, of explorations that were not supposed to have happened, of capabilities that conventional history does not acknowledge. Whether those whispers are real or imagined, whether they represent genuine echoes of a lost past or simply the noise of our own wishful thinking, is the central mystery that has occupied us throughout this investigation. What we have learned is that the evidence is far more ambiguous than either the most ardent believers or the most dismissive skeptics would have us believe. On the one hand, the maps do show some remarkable features, details that are difficult to explain within the conventional narrative of Renaissance cartography. The Piri Reis Map accurately depicts portions of the South American coastline that had barely been explored by Europeans in 1513. It shows rivers, bays, and coastal features with a level of precision that suggests access to detailed source maps, maps that may have been created by earlier explorers whose identities and methods remain unknown. The southern landmass on the map does bear a superficial resemblance to the coast of Antarctica, and when compared to modern seismic profiles of the subglacial topography, there are points of similarity that are intriguing, if not conclusive. Similarly, the Orontius Finaeus Map shows a continent in the position of Antarctica, with features rivers, mountains, coastal embayments that some researchers believe correspond to the real geography of the continent as it would appear without ice. On the other hand, close scrutiny reveals significant problems with the hypothesis that these maps are based on ancient surveys of an ice-free Antarctica. The resemblances between the maps and the actual Antarctic coast are not as precise as proponents claim. The Orontius Finaeus Map shows a continent that is too large, incorrectly oriented, and missing key features such as the Antarctic Peninsula. The Piri Reis Map's southern landmass is connected to South America rather than separated by the Drake Passage, and its shape can be plausibly explained as a distorted continuation of the South American coast rather than a depiction of Antarctica. The longitudinal accuracy of the maps, which Hapgood and others claimed as evidence of advanced ancient technology, turns out to be no better than what we would expect from Renaissance-era navigation and map-making, with systematic errors that are characteristic of pre-chronometer methods. Most critically, the geological evidence from Antarctica itself contradicts the idea that the continent was ice-free at any time in human history. Ice cores and other climate records show that Antarctica has been covered by ice for millions of years, with no warm periods sufficient to expose the coast during the time when humans could have mapped it. The most likely explanation, supported by the majority of historians and cartographers who have studied the maps in detail, is that they are products of their time, compilations based on contemporary exploration, older medieval and classical maps, and a good deal of speculation to fill in the unknown regions. The southern land masses shown on the maps represent not ancient knowledge of Antarctica, but rather the long-standing tradition of depicting a Terra Australis, a hypothetical southern continent that was believed to exist for reasons of geographical symmetry and balance. When explorers finally discovered Antarctica in the 19th century, it was tempting to see it as the fulfillment of this ancient prophecy, and to imagine that earlier maps had somehow anticipated its existence. But in reality, the resemblance is more a product of selective interpretation and wishful thinking than of genuine cartographic accuracy. Yet even as we acknowledge the weaknesses of the ancient Antarctica hypothesis, we should not dismiss the maps as worthless or uninteresting. They remain fascinating documents, rich with information about the state of geographical knowledge in the early 16th century, about the sources available to cartographers like Piri Reis and Orontius Finaeus, and about the ways in which maps were created, copied, and compiled during the Age of Exploration. The Piri Reis Map, in particular, is a valuable historical artifact, one of the few surviving examples of Ottoman cartography from this period, and it provides insights into how knowledge was exchanged between the Islamic world and Christian Europe, how maps from different traditions were synthesized and combined, and how new discoveries were incorporated into existing frameworks of understanding. The map's annotations, in which Piri Reis describes his sources and methods, are an invaluable window into the mind of a Renaissance cartographer, showing us how he worked and what he knew. Moreover, the debate over these maps has had the beneficial effect of drawing attention to questions that mainstream archaeology and history have sometimes neglected. The end of the Ice Age was a time of dramatic change, a period when sea levels rose by more than 100 meters, coastlines shifted, climates transformed, and human populations were forced to adapt to a rapidly changing world. Much of the land that was inhabited during the Ice Age is now underwater, and the archaeological record from this period is fragmentary and incomplete. We know that humans were more mobile, more innovative, and more capable than was once believed. There is growing evidence of long-distance maritime trade, of cultural contacts between distant regions, of sophisticated technologies and social organizations that predate the rise of the first cities and states. The mystery of the ancient maps, even if it does not provide evidence of a lost advanced civilization, reminds us that there is much we still do not know about the deep past, and that the story of human history is more complex and more surprising than the simple linear narrative we are often taught. What then should we make of the Ice Age mapmakers? Should we accept them as real, as evidence of a lost civilization that explored the world and left behind fragments of knowledge that survived in maps and myths? Or should we dismiss them as fantasy, as the product of misinterpretation, wishful thinking, and the human tendency to see patterns where none exist? The answer, as with so many questions about the distant past, lies somewhere in between. The maps are not proof of an advanced Ice Age civilization, but neither are they simple forgeries or fantasies. They are complex documents created by skilled cartographers working with the best information available to them, information that came from many sources, some reliable and some not, some ancient and some contemporary. They reflect both the real geographical knowledge of their time and the imaginative speculation that filled in the gaps. They are, in short, products of human curiosity, creativity, and the eternal desire to know and understand the world. As we close this investigation, we are left with a sense of wonder and uncertainty, a recognition that the past is not a fixed and knowable thing, but a puzzle with missing pieces, a story with gaps and contradictions, a mystery that will never be fully solved. The maps of Piri Reis, Orontius Finaeus, and the others we have examined will continue to fascinate and provoke debate, because they touch on fundamental questions about who we are, where we came from, and what we are capable of. They remind us that history is not just a matter of facts and dates, but also of interpretation and imagination, of weighing evidence and making judgments in the absence of certainty. They challenge us to remain open to new discoveries, to question our assumptions, and to recognize that the conventional narrative of human history, while well supported in many respects, is not complete and may never be. Perhaps the greatest lesson of the Ice Age Mapmakers' mystery is that the search for knowledge is an ongoing process, a journey rather than a destination. Each generation of scholars builds on the work of the previous generation, discovering new evidence, developing new methods, and refining our understanding of the past. What seems certain today may be questioned tomorrow, and what seems impossible may become plausible as new technologies allow us to explore places and examine artifacts that were previously inaccessible. The submerged coastlines of the Ice Age world, the ancient libraries that were destroyed, the knowledge that was lost or forgotten, these are not gone forever. They are waiting to be rediscovered by underwater archaeologists exploring the continental shelves, by linguists decoding ancient texts, by geneticists tracing the migrations of ancient populations, by historians piecing together fragments of evidence from many different sources. And so, as you listen to these final words, as the narrative of the Ice Age Mapmakers draws to a close, consider the broader implications of this mystery. Consider how much of the past remains unknown, how many stories remain untold, how many civilizations rose and fell without leaving clear traces in the historical record. Consider the possibility that our ancestors were more capable, more adventurous, and more knowledgeable than we have given them credit for, not because they possessed magical technologies or were visited by extraterrestrial beings, but simply because they were human, driven by the same curiosity and determination that drives us today. Consider the maps themselves, those fragile pieces of parchment, worn and faded by time, yet still capable of provoking wonder and debate centuries after they were created. They are not proof of ancient astronauts or lost continents, but they are proof of something equally remarkable: the enduring human desire to explore, to understand, to map the world and our place in it. The mystery of the Ice Age Mapmakers may never be definitively solved, and perhaps that is as it should be. Mysteries have value beyond their solutions. They inspire us to ask questions, to seek knowledge, to push the boundaries of what we think we know. They remind us that the world is larger and stranger than we can fully comprehend, that there are always new discoveries waiting to be made, new insights waiting to be uncovered. As long as there are mysteries like this one, as long as there are maps that challenge our understanding and artifacts that do not fit neatly into our narratives, there will be explorers and scholars willing to pursue them, to investigate, to debate, and to keep the conversation alive. And in that pursuit, in that endless questioning and seeking, lies the true spirit of exploration, the drive that has taken humanity from the caves of the Ice Age to the stars themselves.